Hello, testing, testing. Is the mic peaking? I don't think so. Alright, hello. Good morning, or afternoon, evening, wherever you are. We are reviewing more Microsoft interview questions today. Woo. Let me get to that Microsoft page. Well, we don't actually need this page because it's review day. I've already written down the questions that have gotten me in the past. First question is 2938. 2938. Leak code 2938. Oh wait, we did this last time. Never mind then. Next question is LeetCode 88 merge sorted array. This sounds low-key really easy. Why did I mark this down? You are given two integer arrays nums1 and nums2 sorted in non-decreasing order, and two integers m and n representing the number of elements in nums1 and nums2 respectively. Merge nums1 and nums2 into a single array sorted in non-decreasing order, so ascending order. The final sorted array should not be returned by the function, but instead be stored inside the array nums1. To accommodate this, nums1 has a length of m plus n, okay? And the last n elements are set to 0 and should be ignored. Nums2 has a length of n. Oh, I remember why I marked this down. It's because it's possible to do this in place, but I did not know how. Excuse me. Okay, we're gonna try doing this in place then. How the heck do we do this in place? So I guess we have two pointers, one pointing to the end of nums1 and then end of nums2. What happens? I guess we keep shoving the... It's in non-decreasing order, so it's in ascending order. So keep shoving the biggest one into the end of nums1, I guess. Yeah, alright, and then advancing the corresponding pointer. And if the element is out of bounds, we'll just return a really small number, like integer time in value. Okay, that works. Hopefully this shouldn't take too long. Also, let me just sign in real quick. I always forget to sign in because it's incognito mode in Chrome. And we are back. Okay, so like I said, we have two pointers, right? Int p1, let's call it p1, is equal to m minus 1. p2 is equal to n minus 1. So while what? p1 is greater than or equal to 0, is it an and or? It should be an and, I think. We'll only stop when both of them are passed, or when both of them are out of bounds. Okay. Should we do it like this? Is it or? You know what? Let's do an or. We'll probably watch out for out of bounds here too. Also, give me one moment while I check something real quick. Okay, all is good. Okay, So we need to get the current element that the two pointers are pointing to. So num1 is equal to nums1 p1, right? That's if we're inbound. So if p1 is greater than or equal to 0, then that's what we return. Else we return integer dot min underscore value. I swear this is like the third time I'm doing this problem, fourth time maybe, and this is only the second time I'm trying in place. What's num2? Num2 is if pointer 2 is greater than or equal to 0, aka inbounds, nums2 p2, else integer.min value. Okay. Oh, we should also track the nums1 pointer, you know, for writing stuff. Let's do write. Sure, let's call it write is equal to m plus n minus 1, I believe. It'll have m plus n total, yeah, total elements, so minus 1. Okay, makes sense. Okay, so if num1 is greater than or equal to num2, then in nums1 we write num1 and then pointer 1 decremented. Krisha Khan says hi. Hello, hi Krisha. How you doing? And else, this is the case if num2 is bigger. Hey Krisha, or Krishna. How's it going? Today is review day. Wait, this is the problem that you actually helped me with last time. I did not know you could do it in place, so we are reviewing it. Else if num2 is bigger, nums2, wait. You write into nums1 equals num2. And then p2 minus minus. Sure. In the end, you don't do anything, right? I have a feeling this isn't gonna work, but we'll see. Wrong answer. Oh, we're close. Case 2 and 3 works, but case 1 does not. What's going on here? 1. Oh no, what's going on? Oh, I know. We never decrement our pointers, huh? P1. Right minus minus. Hey, there we go. There we go. Okay. I probably shouldn't have to review this question ever again. That was fast. Next up is LeetCode 54. Spiral matrix. Oh no. This one isn't hard, it just takes a long time, right? Given an m by n matrix, return all elements of the matrix in spiral order. Okay. It's just a bunch of if statements, is it not? and a bunch of constraints on what the border of where you can move is. Okay. Where do we even start? Oh man, I kind of don't want to do this because it's just really tedious. Oh well, it's good practice. So row column, where do we start off as? 0. Column, we start off as 0, 2. We start off in the top left corner. Okay. Should we store our boundaries too? So we have our right bound. It's equal to matrix. Is it guaranteed to be m by n? Oh, no. It could be different. Okay. So the right bound starts off as matrix 0.length. Here. Int. Bottom bound is equal to what? The number of rows. So matrix dot length, probably -1, huh? Because we're talking about indices here. What's the left bound? Int left bound is equal to 0, and then int top bound is equal to 0. Okay, so these defined where we can move, you know, during each like directional movement. This way, this way, this way. So this direction is bounded by the right bound. Okay. We are returning a list, right? Okay. List integer. The result, I guess, is equal to new array list, which is fast. Okay, the stop condition is if we filled up all the elements in the matrix, right? So we need to figure out how many elements are in the matrix. Int elements is equal to matrix dot length times matrix 0 dot length. Sure. So once again, the stop condition is while result dot size is less than the number of elements, meaning you have more elements to process. Okay. Okay. First you go right. Yeah, you go right. Braggy3030 says, hey there, I love your streams. I just dropped followed. I'd love to join your fan community. Could you add me on Discord? My username is that. Oh, thank you. I appreciate it. Unfortunately, I don't really give out my Discord username though. Yeah, nothing against you. That's just how I work. Yeah, I appreciate it though. Thank you. Result.size is less than element, so okay. We go right at first. How do we go right? While the column is the column is less than or equal to the right bound, then we keep moving to the right. Alright, so is that how it works? So result dot add matrix row column. Is that how we should do it? Are you going to run into an issue where it double counts the 3 over here? Column plus plus. Should we do that? I'm so paranoid. So the right bound is here, right? What if the column is here? Less than it? Yes, okay. Is it still going to reach it? If column is less than the right bound, so what happens if it's equal to it? This one, it's not going to... Yeah, okay. That should be fine. Next we go down. While the row is less than bottom bound, you add the row and column, the row plus plus. Shoharu says, hello. Oh, hey Shoharu, how you doing? You know, I want to do a sanity check. Let's print out the result, or return the result. Let's also just break so we don't run forever. Okay, for now, just temporarily. So we should print out 1, 2, 3, and then 3, 6, 9. 1, 2, 3, 6, 9. Okay, that is wrong. Where did this 3, 6, 9 go? Oh wait, that's going to be handled by the bottom one, right? Okay, that should be fine. Shoru says, hasn't that been done before? This problem? Yeah, today is review day. I'm reviewing the problems I've gotten me in the past. And this one got me really good. I remember this one took like an hour or something. It was horrible. So hopefully it should not take that long. Next up is left. So while we're doing the column again, right? While column is less than or equal to left bound, we still add it to the result as usual, but this time column minus minus. Also, I realized I never update the right bounds, huh? Any of the bounds. It's okay. We'll handle it later. Left. Next up is top. So while top, the row is greater than, this should be greater than 2, right? We're decreasing all the way to 0. And then row is greater than top bound. Add the current thing to the result, and then row minus minus. And then you continue. Okay. Over here, we should update our top bound, right? Top bound minus plus plus. When we're going down, we update our right bound. Right bound minus minus. Down, when we go left, bottom bound minus minus. Because we're restricting the last row, right? And then when we're going top, the left bound, we already solved this column, so no need to look at it again. Shohuru says, chat, I want to sleep. Ganbatte. Oh, no worries. Oyasumi nasai. Thanks. We update the left bound plus plus. Is that how it works? So here we go through the 0th column, right? Yeah, so the next will be the 1. Okay, that makes sense. I remember for whatever case. Well, let's run this. Oh, that's not good. What's going on here? 1, 2, 3, 6, 9, 8. Huh. Are we now calculating? Ooh, interesting. Ooh, this is really interesting. Are we not? When does it stop? 1, 2, 3, 6, 9, 8. It's always on the left stroke. Why is it stopping on the left stroke? Is something wrong with the top stroke? If row is greater than top bound, why is it not doing the top bound? Is it already failing the top bound thing? What happens when we do top bound here? Column is less than right bound, top bound plus plus. Is there something wrong with our top bound? It starts off as 0 and it becomes 1. Oh, wait. So it becomes 0 and then 1 over here. Is that going to affect it? Oh. I'm so dumb. We literally break here. No. I set myself up. Run. Oh, that's not good. Time limit exceeded. No. Why? While result.size is less than elements. Wait, I don't get it. Is less than elements matrix.length times matrix 0.length. Why would it not reflect it? Huh, I don't get it. Why would it be infinite loop? The number of elements is indeed matrix.length times matrix 0.length, right? Result.size less than elements. Oh no. How do we even have a stop condition? What if we do... Huh. Should we print out what the result.size is? System.out.println result.size. Is it even going to print if it's an infinite loop? Apparently it's on 6 the entire time. Okay, well, good news, it does print if it's an infinite loop. Why is it on 6? 1, 2, 3, 4, 5, 6. Is it actually stuck over here? Huh. Why is it not going up? Result to add matrix while row is greater than top bound. What the heck is even is top bound over here? 1, 2, 3, 4, 5, 6. Okay, so it's definitely not doing well in the top bound here. While the row oh. Wait, I'm increasing the boundaries. I'm updating the boundaries at the wrong places. It shouldn't be every single loop. Dang it. It should be after after we do the entire section. No. Left bound plus plus, so who knows? Yeah, the top bound would have been some really stupid number. Run. Please work. Oh look, it's getting to 8 now though. That's good news. Okay, now why is it doing this? I think it's a good idea to print out which number we're adding. Matrix, row, column. Oh, this is pain. I regret trying to do this again. Left bound plus plus. Is this a good idea? Is it even curling the right way? This, then this. Run. Okay, so what are we doing? 1, 2, 3, 6, 9, 8, 7, 4. Okay, that's fantastic. So we're missing the 5. Why are we missing the 5? What is even the right bound? Right bound minus minus. Let's print out what the right bound is. System.out.println right bound plus right bound. Maybe the right bound isn't updating right. Wait, so originally it's this, right? And then now it's this. So if it's here, it should be able to go here. Okay. Run. Okay. 0, 1, 2. Right bound is 2. Right bound is 1. So we do 4. Oh. Oh, wait. And then we should be going down, right? Huh. Oh. We should technically be going down, right? No. Down while row is less than bottom bound? Wait, I'm getting so confused. Column? Wait, if we're going right... Okay, now we're going down. Should we be updating the right bound? Hoi to the hoi hoi. Oh, hey Threeve. How you doing? Nice to see you again. I am so stuck on this problem. Should we print out what the bottom bound is? Bottom bound. So ideally I wanted to print out the 5 here as bottom bound. Oh, matrices, they're cute. Yeah. Look at it. It's so small. Yay. They're so pain though. Actually, matrices are a lot like human babies. They're really small, but they take a lot of effort. No. Should we print out what the current row and columns are? Man, I'm actually printing out so much stuff. Row column is equal to plus the row plus the column. So, in case you're wondering what's going on, I'm literally going from like here, 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 but I'm not printing out the 5 for whatever reason. Kind of annoying. Print out the 5, you. I'm hoping if I print out enough stuff, I'll be able to tell what's going on. When in doubt, print stuff out. Opolymixida, okay. Where are you? 0, 0, right bound 2. Okay. It prints out 1, 2, 3, 6, 9, 8, 7. We're now at 1, 0. The right bound is 1, okay, so we print 4. RC is now 1, 1, so 1, 1. Bottom bound is 1. Uh-oh, that's a problem. No, that is actually a problem. How do we handle this? Well, row is less than bottom bound. Man, how do we get it to print here? That's really problematic. So it is a matrix and you gotta print an array with every number so it makes a spiral from 1 to the center. Yeah. And it can be any size matrix too. I swear I'm getting off by 1 error. It's not fun. Okay, I see where the issue is now though. The question is how to resolve this. When my row column is at 1, 1, it does not enter into this loop because the bottom bound is already 1. Very not fun. Should I literally just... Is it always going to do this? If it is, then we could do something like at the very end result add this. I'm not sure if this is consistent behavior though. Alright, what's wrong with case 2? 1, 2, 3, 4. Dang, really? So it works perfectly for case 2 for whatever reason. If it's so dumb. If result.size is less than the elements, then we add the last element in. Yay. I swear to God. I don't know if this works though. This is only 2 examples, and it's a really hacky solution. I see a lot of code. What are you trying to do with it? Oh, okay. Wait, let me submit this first. No. Output is 6979. 697. Should we actually break over here? It's so dumb. If dot size, or if it's greater than or equal to elements minus 1, break, use the test case. Submit. Hey, it worked. Woo! Okay, Deepak says which language? This is Java. Can you also print column to see what happens at that point? Print column. Print column. Which part though? There's lots of places where... Here? Oh, I see. At that point, huh? I think I know what happens at that point though. At the test we just failed. I think the issue is we're going down, right? Well, we're going all the way to the right here because that matrix was just 1 row, right? Technically, once we go past this loop, we've already added every single element into the matrix. So then we're going down, and then we're trying to go right, which is bad because we've already looked at every single one, right? So over here, during the middle of the numbers we add, we check if we've already finished. That's basically what I've done. But yeah, Thrive is asking for an explanation. I'll explain it. It's so stupid. Okay, so yes, we want to add all the numbers in the matrix to a list, right? Okay, so this is my current row and column that I'm currently on. I track the boundaries for which I can move. The right bound means that's the furthest right I can move. Bottom bound is that's the furthest bottom I can move. Left bound is that's the furthest left I can move, and so on. So while the result.size is less than elements minus 1, let me just get rid of all these print statements. Yeah, okay. Elements is equal to the total number of elements in the matrix. So while you have now processed every single element in the matrix, you try to move right over here. So while the column is less than the right bound, you move right and keep adding the element there. Let me get rid of these print statements too. Yeah, keep adding to the column, which moves you right, and adding the element. And after that, you restrict your top bound because you've already looked at this column, right? You don't need to move that much up again. Next, you move down. So while row is less than the bottom bound, you move down, keep updating a row, etc. Yeah, in the middle here, I guess you have to check if you've completed your your spiral yet, because as we've seen in that really niche test case, if it's only just one row, you risk the chance of it moving backwards again, even though you've already looked at it. Yeah. Lazar says, what site is that? Oh, it's called LeetCode. Yeah, LeetCode. Where do I type this? LeetCode.com. I cannot type. And then you move the same with the left. Keep going left until you cannot anymore. Column minus minus, update your bottom bound. Go to the top. Apparently in some rare cases, you risk having a case like this where the constraints kind of don't let it get to the center here. So I checked for that and then manually added in the last element. Yeah. Hopefully that answers your question, Threeve. Lazar, this is LeetCode.com. It's basically a really popular site where you can practice coding interview questions. All right, we've done 2 questions. We're like really close to the end of our review list. Next up is LeetCode 3. LeetCode 3. Longest substring without repeating characters. Given a string S, find the length of the longest substring without repeating characters. Okay, the answer is ABC with the length of 3. BC. A. You know what? I remember this, but it's good to review. How do we do this? This is a sliding window, isn't it? We could totally do a sliding window here. So you start here, 2 pointers, one, well, both start at the start and the beginning. And you're like, okay, expand the second pointer A, B, C. The first one remains at the 0th index. When we get to A, we're like, okay, we should probably maintain a hash map of our new characters too, right? Well, the characters that we've seen. So yeah, we expand. Are there any limitations in terms of memory or program speed? Oh yeah. How do I do this? Ooh. Yeah, if your program is too slow, it's gonna say time limit exceeded. I don't know if there's any memory restriction actually. I've never gotten a memory, like too much memory before. But yeah, sometimes if your solution takes too long, it will time you out and say it's a wrong answer. So your solution has to be kind of efficient. Okay, we can totally do a sliding window. We have the second pointer expands. We go to A, we're like, oh, we have a duplicate character now. So then we shorten, we contract our first element. Oh, give me one moment. Alright, I'm back. I feel like that could work, sliding window. And every time we have repeating characters, contract the window in an effort to, you know, get rid of the duplicate number that we just seen. Okay. I feel like that's good. Let's do this. So we have 2 pointers. Int start is equal to 0. Int end. 3 primes is happy. No. November, by the way. Oh yeah, it's November. Oh, did you guys do anything for Halloween? I didn't. I just kind of stayed home and chilled. End is equal to 0. Let's make a hash map of wait, should we do a hash map? Sure, let's do a hash map of the character and the count. Count is equal to new. You watch Programming Horror's funny video? New hash map. I've never heard of that. Programming Horrors. Maybe I'll watch it later. There. Okay, what do we do here? Find the length of the longest substring without repeating characters. There's some funny programming word crimes video. Ooh, really? There's a whole programming niche on YouTube that I'm not familiar with. While I press enter instead of space. Oh, instead of 1 quotation mark? Huh. I'm not sure if I get that one. I pressed enter instead of quotation. I don't think that's ever happened to me. So while and wait, what is the stop condition? If we reach the end, that should be it, right? Is less than s dot length, I guess? Sure. I mean, best case, we just expand end to the end. When can I send their message on chat? Wait, what does that mean? When can I send their message? Oh, was it a typo? Okay. End is less than s dot length. Okay. So what do we do here? We expand end, right? N plus plus. Wait, no. We first get the current substring or the new character. Character C, the current character that we've expanded to, is equal to s dot character at and okay, and then we add into our hash map. Int current count is equal to counts dot get or default 0. Okay, and if it's equal to 0, then there's no problem. We just keep going, right? Okay. And else if the current count is not equal to 0, if current count is greater than 0, then we have trouble. That means we need to contract our start and try to get rid of that duplicate character, right? Okay. How do we get rid of the duplicate character? Start. Okay. Character, start character is equal to s.character at start, I suppose, before we try to contract it. And then start plus plus. Okay, if start character is equal to, oh no, we have to update all the counts too. Int start count is equal to, my brain, it hurts. I made a syntax error here too. C0. The start count is equal to counts.getDefault, the start character default 0, though it's pretty much guaranteed to be in there, right? Because we've already seen it. Counts.put start character and start count -1. We update the count. And if the start character was actually just the current character, that means we decreased it to 0, right? So, wait. So I guess we keep doing this while the current character's count is 0? What until it becomes 0, I guess? While counts.get or default c default 0. I mean, it's pretty much guaranteed to be there, right? So while counts.getC is greater than 0, yeah, okay. Then we keep doing this schmick until we get rid of the duplicate character. Yeah, okay, that makes sense. Velveteen says, hey chat. Hey Velveteen, long time no see, how you been? So if current count, we don't even need this, right? This if statement, it's basically doing the same thing as the while loop, okay. But that means we might need the get or default thing, or default C with 0. So while we have the duplicate character, we keep getting the start character start plus plus. Start count is equal to counts.getOrDefault. Okay, get the count and then decrement it. Okay. Alright, just woke up. Hey, nice. Lazar says, what does the function counts.getOrDefault do? Oh yeah, so in Java it's really dumb. This is a map. I think it's called a map or dictionary in Python or whatever. It basically maps a key to a value, like a map or a dictionary in other languages. If I just do get, like counts.get blah, this is fine if blah is already a key in the hash map, but if blah doesn't already exist as a key in the hash map, this is going to return a exception, like a key not found exception or something, or element does not exist. I forget what the exception is called, but if we put a default value, like get or default, 0, if blah doesn't already exist as a key, then we don't return an exception. Then, if blah doesn't already exist as a key, we return 0 by default. Yeah. Yeah, nice. Yeah, Java just kinda, it's very explicit like that, I suppose. So once again here, get rid of duplicate character, sure. And then you put in, so after here, the count of C is guaranteed to be 0, right? So we should just put in count.put C1, I guess. Sure. And then we need to track the length of the longest substring, right? Man, we haven't done any sanity checks up to this point. This is kind of bad. We should do one soon. Int longest substring is equal to integer dot min underscore value first. Okay, and every time we loop, longest substring is equal to math.max of the current longest substring and end minus start plus 1. It should be plus 1, right? Because if we just have the first element, the first character, n minus start is 0 plus 1. Okay, sure. And then you return longest substring. Okay, this is probably not going to work. We did not do any sanity checking. Well, end is less than s.length. Is it this? Run. Out of bounds exception. s.character at start. Really? We're at that? While counts.get or default, should we actually do a well, start is less than the end, and that because the end is bounded by s.length. Okay. Time limit exceeded. Okay. And do we ever update end anywhere? No, we don't. That's bad. End plus plus. Dude, it worked. Oh. That's crazy. Dang, bro. Dang. Submit. If this works, that'll be crazy. Dude, we're really close though. Expected 0. Okay, I know what's going on. Longest substring should default to 0. Let's use this test case just in case. Nice, submit. Hey, let's go! Woo! Sliding window. Okay. I think that's enough problems for today. Next up, we will do system design study. Give me one moment while I get my materials. Downloads. Alex Shu, where are you? Okay, so in case you're new here, this is the part of the stream where I will be much more quiet because I will just be, reading and taking notes. So, system design, we are learning how to design the internals of YouTube now. Yay. Last time we read the high-level design overview, right? Okay, so this is the upload. This is how you upload a video. The user uploads the video to a blob storage. Lazar says, do you work somewhere or this is your hobby? Nope, neither. I'm trying to get an engineering job, so I'm studying right now. I'm job hunting right now. Okay, so the user, when they want to upload a video, what do we do here? They upload the video through a blob storage, right? And then some transcoding servers convert the video into a more streamable format. Like if the user enters if they upload a video in like .mov format, we want to convert or transcode the video into like MP4, MPEG, whatever stream format YouTube uses, and in multiple resolutions too. And then it stores the transcoded videos on a separate blob storage, and then it updates it on a CDN too. A CDN is like a sort of a cache server. Yeah, that's located close to the user geographically, so it's fast to stream from. And then when the transcoding is complete, you add it into the completion queue. The completion workers update the metadata in the databases to confirm the fact that it's completed, you know? And everything else goes through load balancer to the API servers. Yeah, when you upload a video, you go through the API servers and it does an initial update of the metadata. Maybe it updates like the title or description of the video. And then the completion handlers come in and update the fact that it's, you know, finished processing, your video is ready to view now, etc. Okay, I remember this. Cool, that's the same thing. And then streaming a video is just this, right? You got the client just pointing to a CDN. Yeah, whichever sort of cache server is closest to you geographically, just stream the video from there. I wonder how it knows which CDN it is though. You know what? That's something to look up. How do users know which CDN to look at? How do clients know which CDN to look at? Wait, it's straight up DNS? Bridges. Which one is a bridge? Is this a bridge? I can't tell. Oh no, am I a robot? That's bridge. There could be a bridge in the distance over here. Is this just like a fancy... I don't know what that is. Big websites use CDN servers, but YouTube has one big domain name. How does DNS know which CDN server to use? So let's say a web page has images, like how YouTube has videos. Those images are on the CDN, and when you load the web page, the CDN will know what server is closely to display the images. These DNS servers map different IPs to the same domain. Oh, okay. The front-end web server that accepts knows which CDN server to use. Lazar said, for the previous task, why didn't you use the tree and based on the ASCII value of characters, enter into the tree and later search the tree to compare new elements? You mean this one? Why didn't you use the tree? Wait, what tree? And based on the ASCII value of characters enter into the tree. Oh, you mean you're using this to find out... Oh, so the tree is used to search, to track duplicate elements, you mean? So trees are... Oh, that's a interesting one. Using a tree. Well, there's not really a convenient tree data structure in Java that I know of. And also tree is log n time. It's a bit slower than a hash map. Hash map is O of 1 time for, you know, key lookup. Tree is a data structure. Oh yeah, I know tree is a data structure. I don't think there's a convenient tree data structure in Java though. Hold on. Java tree data structure. Java tree. Oh look, there's a tree here. Java, is there a built-in tree data structure? Hash tree. Oh, we have a hash tree. Java hash tree. Tree map? Oh, tree map. All right. Java tree map. Runtimes. It's pretty quick. Complexity of a tree map. I see. So it sorts the keys by with the tree, right? Okay. You have red black tree? Dang, red black tree. Isn't that kind of overcomplicating things? Also, I feel like I think that would work what you're talking about, storing all the keys, all the characters in a tree. But I feel like that would be slower, no? What I'm looking at here, well, in general, tree lookup times are like log n time, right? Because worst case, you get to search through the height of the tree. Hash map is O of 1 time for key lookup. Tree is log n time. Is it not? Wait, hold on. Could I literally just... Could I just do a tree map here? Tree map. Tree map was new. Tree map. Run. Look, it worked. Nice. Okay. Yeah, it's a bit slower. We got like 30-something%, right? For the hash map. Tree map gives us 14% speed. Wait, let's put it back into a hash map. Hash map. Yeah, I think hash map is better because again, for hashing, key lookup is O of 1 time. Tree map is log n time because, you know, tree data structure. So Anycast gets the user to the nearest DNS server DNS resolves domain names, okay. Anycast, okay. Huh, okay. Okay. So apparently CDN, the exact CDN server, I feel like this should be, so for CDN, okay, so the location, the exact CDN server is determined by DNS and some other third-party stuff, right? Very interesting. So your front end isn't actually involved at all. Okay. Huh, wait, actually the front end is involved. Okay, never mind, the front end is involved. But they kind of just abstracted out like this, right? Okay, that's fine. Design deep dive. Okay, yes, video transcoding, make it streamable. Okay, so transcoding a video. This sounds important. Transcoding. So there's many parts to transcoding a video, right? One is basically to convert it to a streamable format, right? Okay, streamable format. And multiple resolutions. Cool. Watermarks. Some provide thumbnail images themselves, and some upload high-definition videos, whereas others do not. Okay. Watermark. Thumbnails, okay. I don't get it. Why are thumbnails in this step? Isn't that a metadata thing that you can just do directly through an API? Directed acyclic graph. Okay, so the process for, transcoding a video can be divided like this in parallel, I guess. Metadata. Thumbnail. Watermark, okay. Okay, video transcoding architecture, preprocessor, DAG scheduler, task workers, okay. Video transcoding architecture, okay. My pencil just dropped. I feel like this is important to know. Let me write all this down. Preprocessor, DAG scheduler, resource manager, task workers, and then encoded video. And then the task workers, preprocessor point to temporary storage, okay. Okay. Preprocessor, video splitting. Dario says, yo, hello. Hey Dario, how you doing? Preprocessor split video by GOP alignment for old clients, okay. Each chunk is okay. So preprocessor splits the video into chunks of a few seconds long. So you split the video into GOPs, DAG generation. So it generates a work process based on configuration files, client programmers write, okay. It generates DAG. Who are the client programmers though? Client programmers write. Client programmers, so are these like predetermined by the programmers at YouTube? Sure. I'll just say, doing great. I have holiday today because Day of the Death. Oh, are you Spanish speaking? Is it called Dia de los Muertos? Have fun, man. Do you celebrate like regular American Halloween? or just Dia de los Muertos? Okay, cache data. Oh, we're still here. Cache data. Cache for segmented videos for better reliability. The preprocessor stores GOPs and metadata in temporary storage. If video encoding fails, the system could use persistent data for retry operations. Oh, you work remotely from Mexico. Very cool. Oh, you're not in America. Whoops. I don't know why I just assumed. Okay, so the GOP also caches, well, the preprocessor also caches in its own memory. Okay. So in case operations fail, you could get the GOP again and then retry. Okay. Okay, what's going on with the DAG scheduler? We decorate for Halloween and have Halloween parties with costumes. Oh, very cool. What are some cool costumes you've seen? I feel like superheroes are popular in my area. The Scream monster used to be pretty popular too. Don't know if it's still popular now. But Dia de Muertos is more popular, I guess. Ooh. Interesting. DAG scheduler splits a DAG graph into stages of tasks and put them in the task queue to the resource manager. Okay. Oh, I see. Very cool. So it splits it into stages of parallel tasks. Split DAG into stages of parallel tasks. Okay. Okay. Very cool. Resource manager, what does this do? Is responsible for managing the efficiency of resource allocation. It contains 3 queues, really? And a tasks at scheduler. Okay. More complexity. Excuse me. Daryl says, I've dressed as superhero many times. This year we did Joker and Harley. Oh, very on trend. That's been talked about a lot this year. Okay, so a task queue, it is a priority queue that contains tasks to be executed. Okay. Worker queue, it is a priority queue that contains worker utilization info. Running queue, it contains info about the currently running tasks and workers running the tasks. Okay. So it picks the optimal task/worker, instructs the chosen task worker to execute the job. Oh. Okay. My notes are getting so complicated. So the 3 queues, the task queue, worker queue, No, it's called the running queue, huh? Worker queue? Oh no, worker queue and then running queue. Contains info about the currently running tasks and workers running the tasks. Okay. So it basically maps the workers to a task, huh? Okay. So task queue is top priority tasks, and then worker queue is, what's worker queue? I imagine they sort it by the most available worker, right? Optimal task worker instructs the chosen task worker to run the task, binds the task/worker info and put into the running queue, yeah. Task scheduler removes the job from the running queue once the job is done. Okay. What if, I'm kind of confused about the running queue. What if the job that's not the most recent on the queue is finished? Advik says, hey chat, sup? Hello, hey Advik. Welcome to the stream. I'm studying YouTube system design again. Task workers. Task workers run the tasks which are defined in the DAG watermark encoder merger thumbnail. Yes. Metadata is frequently accessed, okay. Caching metadata in memory is a good idea, okay. Commonly used metadata, okay. For video or audio data, we put them in blob storage. Okay. Data in temporary storage is freed up once, okay. I messed up on my notes, haha. Time to get out the eraser. Okay, so metadata is usually in a cache. And then video and audio are used in blob storage, okay. That makes sense, okay. So I assume these are all the data that's currently being worked on, like the video or audio that we're currently working on. And then metadata is in memory. Video audio is in blob storage, okay. Encoded video. Okay, and then in the end, we spit out the encoded video. Very nice, okay. Okay, system optimizations. You know what? I'm pretty satisfied with the progress I made today. I think I finally understand all this entire graph. It was tough, but I managed to do it. Okay, I think that's all for today then. Next time we're going to look into system optimizations for the YouTube system design. I think that's pretty much it. Oh, also, I have some exciting announcements. There is another coding battle on November 2nd. Is that Saturday? Yeah, that should be Saturday. I'm battling Yohua at 2 p.m. PST. Yohua is a crab YouTuber. I think he took some intro level programming courses, but yeah, he seems like a fun dude. He's Spanish speaking too. Yeah, I think I'll try to match his pace that day. So it'll be a more fun battle. It's not gonna be like me versus Sunzalore. Oh. Wait, isn't that tomorrow? Yeah, that's freaking tomorrow. Yeah, the battle is tomorrow. I forgot. Heck yes. Yeah, watch out for that. Otherwise, this is where I'll stop the stream then. Thanks everyone for coming. Thanks Advic. Thanks Dario, I appreciate. Alright, bye guys. See you tomorrow. Bye Velveteen. Bye Threeve. Oh dang, you guys are still here? I did not know. Thank you. Is there someone I can raid right now? Is there anyone streaming right now? Thanks Dario. And nobody I know is on.